is 6/8. Now they've drawn this circuit funny. I'm going to turn this up. So look at how it's drawn. I'm going to turn it up so it looks the way I want it to, which I always like to put the battery over here. And the battery comes out and goes through a parallel circuit. So I'm going to draw my parallel resistance like this, just because it's easier. You can redraw these as long as you show them in the same form they were in. And this. So this is an equivalent circuit to your figure 6/8. We don't know what voltage total is. Voltage total, we don't know. We know our total current is 6 amps. What else do we know? We know the current through R1 is 4 amps. And we know R1 is 10 ohms. We know R2 is 10 ohms. Or R3 is 10 ohms. So we know this is 10 ohms. We know R3 is 10 ohms. We don't know what R2 is. Okay? So this is where we're at. And again, it's a puzzle. And we want to start solving this puzzle. You know, I total equals 6 amps. So the first thing I see that I can solve is this node. Because I know that all the current entering a node has to equal all the current leaving a node. Okay, so I know I got 4 amps going up. I don't know what current's going through R2, but I know I got 6 amps coming in. So 6 amps are coming into the node, 4 amps are going up. So 2 amps must be coming down because that's what's left. So I know IR2 equals 2 amps. I know IR1, they gave this to me, is 4 amps. So now I can solve for the voltage drop at the top one, right? And VR1 is equal to IR1 times R1, which is 10 times 4, so that equals 240 volts. So I got that solved, right? I know both of those currents at 4 amps and the 2 amps come back to this node, right? So I got 4 amps coming back down, I got 2 amps coming up, which means I'm back to my total current, 6 amps, which goes through the rest of the circuit. So IR3 is 6 amps. I know that because I got total current there, right? So 6 amps going through there, that means my VR3 is I times R, 6 times 10 is 60 volts. So now I can solve for my total voltage because I have a loop. If I do my voltage loop through there, through here to the back, I got 40 volts and 60 volts in that loop. Those are only resistors in that loop, which means my V total equals 100 volts. Okay? Okay. Well, I also know in parallel that voltage is the same. So I got 40 volts on this parallel resistor. I must have 40 volts on that one too. So VR2 is also 40 volts. And now I can solve for R2. R2 equals V over I, which is 40 divided by 2. That's 20 ohms. And we have now solved for everything in this figure. Again, it's just a puzzle. We apply our knowledge, really 4 things. Our series equations, our parallel equations, Kirchhoff's current law, the current on the nodes, Kirchhoff's voltage law, the voltage in a loop, and we can solve for all the problems we have.